Join fast, okay? I'll wait for one more minute. Please tell them to join. So I'll share my screen now. Can you see the screen? Hello? Can you see the screen? Okay, Anjita. Okay, sure. Okay, Punya. So, where did we stop last class? I think we stopped with this series, isn't it? We were trying to write the generating function given a particular sequence of numbers. You will be given a sequence, an infinite sequence of numbers, and we have to write down the function corresponding to this sequence, isn't it? Do you remember what we had discussed in the last class? Any infinite series given to you, you can converge it into a formula as a function. And this function will generate all particular sequence, all particular elements in this sequence, all terms in this sequence. Okay, so we have to find out a closed formula corresponding to a given sequence. And we applied the multiply, shift, subtract method, isn't it? So the same method is used for finding out any sequence. Given any sequence, you can find out the generating function using the same method. Okay. Am I audible to you? You have to write it down along with me, okay? I will upload notes only at the end, so you have to write it down along with me. Is it clear? Okay, Anurag, okay. So let me move on to the next series, the next sequence of numbers. I think it is the 8th one, right? The next sequence is 1, 1, 0, 1, 1, 1, etc. That is, when 0 comes in between, what will you do? How will you find the, how will you write down the generating function? If something, some sequence, if some number is missing in the sequence, okay. So how can we find out the generating function? Now, what is the general form of g of x? What is g of x? It is an infinite polynomial, isn't it? How will you write g of x? What is the general formula of g of x? 1 plus, what is the formula? A0 plus A1x, isn't it? Here I wrote 1 because here the first sequence number is 1. So general form, let me write the general form. If you forgot, let me write the general form. A0 plus A1x plus A2x square plus A3x cube plus etc. This is the general form of the polynomial, and here A0, A1, etc. is the given sequence. This is A0, this is A1, A2, A3, A4, A5, etc. This is an infinite sequence. So in this formula, in this general form, and this is what we call as the generating function g of x. And in this g of x, we are going to substitute the values for a0, a1, a2, a3, etc. And we are given the values also in the question. That is, a0 is the first term, a1 is the second term, and so on. So we get g of x as g of x is equal to a0 is 1 here. So 1 here actually the term is x raised to 0. Since x raised to 0 is always 1, we just write the first term here. So a0 is 1, x raised to 0 is 1, plus then a1 is again 1 into x. So 1 into x, I'm just writing it as x. Then next, what is a2 here? What is a2 here? What is a2? What is a2? What is A2 in that sequence? 0. Very good. So if it is 0, then should you write that term? Will that term be there in the polynomial? This is an infinite polynomial, right? Will that term be there? A2 has turned out to be 0. So this particular term is absent in that sequence. So that is x square is not there, isn't it? So 0 into x square, you get 0 into x square plus what is a3? A3 is again 1. So you get x cube, 1 into x cube is x cube plus x raised to 4 plus and so on, isn't it? So this term turns out to be 0. This turns out to be 0 and this becomes 1 plus x cube plus x raised to 4 plus etc. Isn't it? So how will you find out the generating function? The general form of the generating function is that this particular term should be there. So what we have to do in order to convert, this is not a generating function. So to convert, this is not the general form. So to convert it into this general form, I want to convert this formula to this general form. I have to add this number, isn't it? I have to add x raised to 2 here. So I'm just converting it to general form. That is, it is equal to 1 plus x square. I'm going to add that term purposely. Plus x cube plus x raised to 4 plus etc. And since this term was not there in the sequence, I'm going to minus it at the end. Okay, now this becomes equivalent to this. These two are now equal now, isn't it? This is now equal because I had added x raised to 2 and then I subtracted it. So this becomes equivalent to the one we had written here, isn't it? Did you understand what I did? Since this x square term was not there, I just added it to make it a general form, to make it this general form, that is a0, or to get all the powers of x, I added x square, and finally from the entire polynomial, I subtracted x square. Now this particular sequence, it becomes a general form, isn't it? This is the general form of our polynomial. And what is the generating function for this? What is the sequence? How will you write the generating function? What is the generating function for 1 plus x square? We had studied it earlier. What is the sequence in this generating function? 1, 1, 1, 1, etc. Isn't it? That is the sequence. The sequence generated here is the coefficients of x. Here it is x raised to 0. So coefficient is 1. The coefficient of x raised to 1 is 1. Then coefficient of x raised to 2 is again 1. So this is the infinite series 1, 1. And I had derived the formula earlier for the sequence 1, 1. What is the formula for this particular sequence? What is the formula? I told you certain formulas you should by heart, isn't it? So one among them was this particular sequence, 1, 1, 1, etc. And what is the sequence? What is the generating function? You have to by heart that generating function. What is the generating function? Anyone? Yes, 1 by 1 minus x. Very good, Akshara. It is 1 by 1 minus x. I think you can see the screen, isn't it? I'll take the next slide. So it is 1 by 1 minus x. Okay. So this is equal to, here you had plus x square. Okay. So this is equal to 1 by 1 minus x. This entire polynomial turns out to be 1 by 1 minus x. And this term you have to write along with this minus x squared. Okay, so the generating function, if for this particular sequence, 1, 1, 0, 1, 1, etc. This is A0, this is A1, A2, etc. So if one term is missing, you have to add that term to the sequence. No, you have to add the term and then subtract it from the sequence. So you get 1 by 1 minus x square as g of x for this particular sequence, 1, 1, 0, 1, 1, 1, etc. 1 by 1 minus x square. Did you write it down? Did you write it down? Any doubts? See, just see that if any particular term is missing, if 0 is there, when you multiply by that particular x power of x, then that turns out to be 0. So, but for a general case, we should have all the terms. So, if anything is missing, you just add the term and then subtract it at the end. Okay. Is it clear? Any doubts? Did you write it down? I won't be uploading notes in the beginning, okay? I will upload it only at the end. So you have to write it down. Write down all the notes. Did you write the notes? Did you write the problem in your notebook? Okay, okay, Adarsh, okay. So shall I move on to the next question? Shall I move on? Did you write it down? Okay, Adarsh. So I'm not getting response from majority or keeping quiet, okay? So let us look at the next sequence, the ninth sequence. 0, 0. See, this question is given for your serious exam, so take it seriously and study well. This is the sequence. All these questions you have to go through. So, given the sequence, how will you find the generating function? How will you find the generating function g of x? You know g of x is equal to a0 plus a bar x plus a2 x square, etc. is g of x. So what is the generating function here? What is a0? a0 is 0 plus a1. What is a1? Again 0. a1 into x plus what is a2? a2 into x square plus a3 into x cube plus a raised to 4 into x raised to 4 and so on. This polynomial continues, isn't it? Now this becomes what? What is this? X square plus x cube plus x raised to 4 plus etc. Isn't it? Please write it down along with me, okay? Now, how can we solve this? How will we find the generating function? What are you going to do? I have to reduce it to a sequence which I am familiar with, isn't it? So that I can, that's why I told you certain formulas you should by heart so that you can apply it in these problems. So how can I reduce this? How can I find a sequence that is, for which the generating function is already known? How will you solve this? Can anyone say a method? What are you going to do with this? How will you solve it? You didn't understand what is going on? I have to find a sequence which I can substitute here. So here I'm going to take x square. This starts with powers of 2, but our polynomial it starts from x raised to 0, and x raised to 0 and x raised to 1 is missing here. So what we have to do is, given from the given sequence, we have to derive the entire x raised to 0 sequence. Starting from x raised to 0, we have to generate the general form. So I'm taking x square as common from this sequence. Now here I get 1 plus. When I take x square out, the remaining here I get x. Here when I take x square out, I get x square plus so on. Isn't it? X cube and so on. Now can I find the general solution? What is this sequence? What is this sequence? What is the sequence generated by this polynomial? What is the sequence generated by that polynomial? This polynomial in brackets. Is it the general form? A0 plus A1x plus A2x square form? Hello? Why you people are not responding? Is it the general form? What is the sequence corresponding to that form? Agarsh, what is the sequence? Yes, Akshara, 1, 1. The sequence corresponding, see, here this is A0, here A1 is 1, A2 is 1 again. So this is the sequence corresponding to the sequence corresponding to this polynomial is 1, 1, 1. And I told you if it is 1, 1, 1, then you should learn that its generating function is 1 by 1 minus x. Isn't it? So here we can substitute instead of this polynomial, I can write x square into 1 by 1 minus x, and this becomes x square by 1 minus x. So this is the generating function for this particular sequence. Okay, is it clear? Is it clear? Shall I move on to the next one? Arunima. Arunima unda? Hello? Okay, did you understand what I said now? Are you writing it down? Okay. So I won't be uploading notes. Okay. So you have to write it down from this lecture. See, why only very few are here? Attendance is very low. I'm going to take the attendance. Now you say attendance. After that, I will continue the class. Say your attendance. After that, I'll continue the class. Number 1, absent.
2,
3, absent.
4,
4,
5,
6,
7,
8,
9,
10,
12,
13,
14,
15,
16, absent.
18,
19,
20, absent. 22, absent. 23, absent. 24, absent.
25,
26, absent.
7,
28,
29,
30,
number
31,
20, absent. Okay. 30, 31,
32,
32. Next, 33.
33,
Next. Okay. 35,
35,
36,
37, absent.
38,
38. Number 38.
38.
39 absent.
40.
41.
42 absent. Okay, 42. 43 present. 44.
44. 44.
45. 46. 47.
48.
49.
50.
51.
52.
53.
54. Absent.
55.
56.
57.
59.
59.
60.
61. Absent. 62.
63.
60. Okay. So I won't be giving attendance again, okay? Here, 62 is present. Now, let me move on to the next question. The next series is 1a, a square, a cube, etc. Now, how are you going to solve this series? What is g of x? G of x is equal to, write it in the form of a0x, a0 plus a1x plus a2x square. When you write it in this form, a0 is 1 here, isn't it? This is a1, this is a2, this is a3. So I think by now you will be able to find out the function by yourself. That is a0 x raised to 0 plus a1 x plus a2 x square plus a3 x cube plus etc. I just substituted the coefficients for the polynomial x raised to 0, x raised to 1, x raised to 2, x raised to 3, etc. I just wrote the coefficients based on the given sequence. So the first a0 was 1 into x raised to 0. Since it's always 1, we just need to write a0 first. So a0 plus a1x. Okay. a0 plus a1x plus a2x square, etc. So now, what are we going to do here? How will we solve this? Just like we had studied the multiply shift operation earlier, I'm going to rub off this, okay, this x raised to 0 since I need to multiply here. Now, we can just multiply this. I want to cancel out these terms, okay? So what are we going to do here? Multiply this by, so looking at 1, if we multiply this 1 by ax, these terms will get cancelled. So you just multiply ax into gx. This gx by ax. So you will get, when you multiply 1, the first term by ax, you will get ax, write it down below ax term, shift and write, so that it is easy for us to cancel. Then again multiply this ax by second term a into x, that is you will get a square x square plus again multiply ax with the third term, you will get a cube x cube plus when you multiply this ax by the fourth term, you will get a raised to 4, x raised to 4 and so on, isn't it? I'm just multiplying g of x by ax. And instead of writing it just below 1, I'm just writing the same coefficient below the next, the coefficients, the polynomials The degree that is similar, I'm writing below the terms that are similar. Then next, what is the third step? I have to minus it, isn't it? As we have done earlier, g of x minus ax into g of x. When we minus it, what will you get? I'm minusing ax g of x from this. So 1 minus here we have 0. So you get 1. Then ax minus ax. Here we have ax. When I minus this term ax, you get 0. So the rest of the terms turns out to be 0. Everything will get cancelled here when I minus it. So this infinite polynomial gets cancelled and it turns out to be 1 here. Okay, next what I'm going to do is from the left hand side, I'm going to take g of x as common into 1 minus ax is equal to 1. So now what is g of x? G of x is equal to 1 by 1 minus ax. Okay, did you get it? So this is that particular method, that is multiply, shift and subtract. So I multiplied by ax, then I shifted this to the next position and then I subtracted it. So using multiply shift method also we can find out the general form, or you have to take, if you find that there are common terms here, you can take it out and reduce to a sequence which you are familiar with and then write the generating function. Okay. Is it clear? Is it clear to you? Any doubts? So let us move on to the next sequence. This was the 10th sequence, isn't it? So let us move on to the next one. 11th sequence. I'm giving you all possible sequences so that you will study it. Okay. 1397. It is the powers of 3, isn't it? So how are we going to write the generating function for this? What is g of x? G of x is equal to, here this is a0, a1, a2, a3, etc. So the general form is a0 plus a1x plus a2x square. So a0 plus a1x plus a2x square plus a3x cube, etc. Now, what are we going to do in the next step? You can apply the multiply, shift, subtract method. So with which term will I multiply this g of x? With which term should I multiply g of x? Can anyone say? With which term should I multiply g of x? Come on fast. Look at the first one and the immediate, yes, very good Niharika, 3x. So when I multiply 3x with g of x, what will I get? 3x into first term, 1, I get 3x. So I write it below 3x. I'm shifting and writing. I can write it here, but when you cancel it, it's difficult for you to compare. So I'm just writing it below. Now, multiply 3x with the second term. I'll get 3 3s are 9, 9x square. Plus, now I'm going to multiply 3x with the third term. I get 9 3s are 27, x cube, plus so on. Now, what is this next step? Come on first. What is the next step? I multiplied, I shifted, and what is the third step? What should I do next? After multiplying and shifting, subtract. Very good. G of x minus 3x g of x is equal to 1 minus 0, I get 1. Then all other terms will get cancelled. Isn't it 3x minus 3x, 9x square minus 9x square, 27x cube minus 27x cube. So everything will get cancelled and I'll get 1 here on the RHS. Now next, I want to find out g of x. So I'm going to take it as common and then 1 minus 3x. Gx is common to these two terms. So I took it as a common term and then I wrote the remaining terms, that is 1 minus 3x is equal to 1. So g of x is equal to 1 by 1 minus 3x. Okay, if you remember this sequence, also if you are able to by heart the sequence, you have to study this so that you can apply it somewhere, okay, in other problems. So g of x is 1 by 1 minus 3x. Is it clear? Is it clear? Any doubts? Any doubts? So if you have any doubt, just interrupt and ask. Okay, if you didn't understand, you just stop me and ask. So moving on to the next series. What was the previous number? 11. Okay. Did we do this series 0, 1, 1? No. So, see, next series. Zero, 1, 3, 9, 27. So the previous one was 13927, isn't it? So here I'm going to add 10 to the beginning. 0, 1, 3, 9, 27. Okay. What will be the what will be the generating function for 0, 1, 3, 9, 27? The previous one was 13927. So the generating function will be different for this sequence when compared to 13927. Again, let us see how you can find it. G of x, it is equal to a0. A0 is 0 here, isn't it? 0 plus a1 is 1, a1x plus a2 3 x square plus a3x cube plus 27x raised to 4 plus etc. So how can we find this? The 0 will cancel, isn't it? So you get x plus 3x square plus 9x cube plus 27x raised to 4 plus etc. Now, what am I going to do? Instead of multiplication, we have to find out whether I can have any common terms and generate and reduce it to a known series. Okay, so if I take x as a common term from here, I will get 1 plus 3x plus 9x cube, 3x square plus 9x cube plus 27x raised to 4 plus etc. Isn't it? A0 plus A1x plus A2x square. Okay, I did. Is it correct for what I had written? Is it correct? There is a mistake in this line. What is the mistake? I have to take x out, isn't it? I'm taking x out from the sequence. So is this correct what I had written? Can you correct that sentence? If I take x out, what will be the sequence? So I don't think you are listening to any of these classes. If I take x out, what will be the remaining sequence inside that bracket? Is that correct what I had written? Three x, isn't it? It is 3x because I had taken 1x out, so the remaining x is here. Then here it is 9x square. Then it is 4x cube. Okay, I had taken 1x out, isn't it? So this is 3x plus 9x square, 27x cube and so on. So now this is a familiar sequence, isn't it? The sequence generated is 13927, A0 plus A1x plus A2x square form. So the sequence 13927, which we had solved earlier in the previous question, we found that the generating function corresponding to this is 1 by 1 minus 3x. So this you have to by heart, okay? 1 by 1 minus 3x. And so substituting this formula here, for this particular sequence, you get x into 1 by 1 minus 3x, which is equal to x by 1 minus 3x. Okay, so this is the generating function for the sequence 0, 1, 3, 9, etc. For the sequence 1, 3, 9, etc., it is 1 by 1 minus 3x. For 0, 1, 3, 9, etc., this generating function is x by 1 minus 3x. Okay, so as the sequence differs, as the series differs, you get different generating functions. Is it clear? Is it clear? Any doubts? So let me move on to the next series. 13th question. 0, 1, 1, 1, etc. What is g of x? G of x is equal to 0 plus a1x plus a2x square plus a3x cube plus etc. So this term reduces to the 0 gets can 0 is not there, so x plus x square plus x cube plus etc. So now how will I find the generating function? Very simple. Come on, how will you find the generating function? Just like we took the x term as a common factor outside, here also we can take the x, isn't it? If I take x out, I get 1 plus x square plus x cube series, which is a familiar series. The sequence generated, this is a polynomial corresponding to the sequence 1, 1, 1, etc. Isn't it? So what is the generating function for that particular sequence? X into 1 by 1 minus x. You have to study this. I told you for these sequences, you have to by heart these formulas. So this turns out to be x by 1 minus x. Isn't it? Is it clear? Is it clear? Okay, okay, Isha. Okay, Akshara. So now, the next sequence. Fourteenth sequence. 2, 2, 2, 2, etc. How are you going to solve? What is g of x? G of x is equal to a0 plus, here a0, a1, etc. are all 2's, isn't it? So a0 plus a1x plus a2x square plus a3x cube and so on. So next, here also we can take the common factor out. 2 is a common factor. So if we take it out, you get 1 plus x square plus x cube plus etc. Now, this is a familiar series corresponding to the series 1, 1, 1, etc. And the generating function is 1 by 1 minus x. You have to study this. Okay, for 1, 1, 1, it is 1 by 1 minus x. So you substitute it here, you get 2 into 1 by 1 minus x, that is equal to 2 by 1 minus x. Is it okay? Did you understand? Okay, Adarsh, okay. So what is the generating function for? Now, 15th question. What is the generating function for 4, 4, 4, 4? The same way you can solve it, isn't it? What is the generating function? The same way how you did for 2, you can do it for 4 also. Instead of 2 by 1 minus x, here you will get the common factor as 4 and you take 4 outside and you will get 4 by 1 minus x, isn't it? G of x is equal to 4 plus a0x plus a1 x square plus a2 x cube, etc. And here if we take 4 as the common factor, you get 1 plus x square plus x cube. I think you can do it by yourself now. That is 4 into, this is the polynomial corresponding to 1, 1, 1, 1, etc. And that is 1 by, generating function of 1, 1 is 1 by 1 minus x. Substitute here, you get 1 by 1 minus x, which is equal to 4 by 1 minus x. So if the series is 2, 2, you will get 2 by 1 minus x. If it is 4, 4, etc., the same number is repeated, then you will 4 by 1 minus x. So whichever number is here, given here, that will come on top. Okay. And if you by heart these generating functions, it is easy. Otherwise, you have to derive and find out. You just if you derive it, you will get the generating function. Is it clear? Is it clear to you? So let us do one more end stop. Okay. 16th one. 2, 4, 6, 8, 10, etc. What is g of x? G of x is equal to a0 plus a1x plus a2x square plus a3x cube plus a4x raised to 4, etc. Now again here also we can take 2 as the common factor out, and you will get 1 plus 2x plus 3x square plus 4x cube plus 5x raised to 4, etc. Isn't it? Then just look at this sequence. It is 1, 2, 3, 4, 5 is the sequence. And also you have to study this sequence also. And I will give you the list of sequences which you should by heart. Okay, you should study that so that you will be able to do these problems. So for 1, 2, 3, 4, etc. for this sequence, the generating function is 1 by 1 minus x the whole square. For 111 sequence, it was 1 by 1 minus x. For 1234 sequence, it is 1 by 1 minus x the whole square. So substituting it here, you get 2 into 1 by 1 minus x the whole square, which is equal to 2 by 1 minus x the whole square. Okay, so this sequence also you should by heart. For 111, it is 1 by 1 minus x alone. If it is 1, 2, 3, 4, 5 sequence, it is 1 by 1 minus x the whole square. Okay. Is it clear? Is it clear? Is it clear? Okay, okay. Okay, so hope you had written it down. Okay, so I think time is up, so thank you. So one more thing. In the afternoon, you have 2 sessions, right? Afternoon, you have 2 sessions from 2 to 2:40 and 3 to 3:40. I will be taking those 2 periods, okay? So thank you.